So today we're learning about further symmetry properties, and Pythagorean identity. And we will start from the Pythagorean identity. If we look on the unit circle, which again very helpful. Unit circle, understanding of unit circle is a key to understanding of the trigonometry of circular functions. And we have point, angle theta, point with the coordinates x and y. And so this, we have right angle triangle. This is a right angle triangle. With this side equal x, this side equals y. And what hypotenuse equal?
X squared of x squared.
1. It's equal 1 because it's a unit circle. Unit circle has radius 1. And let's apply Pythagoras. We have x squared plus y squared equals 1. And what x equal? When we have point on the unit circle, what x coordinate? Cos and y coordinate? Sine. So we get Pythagorean identity, cos squared theta plus sine squared theta equals 1. By the way, when you will be using calculator and need to use sine squared, you need to type in the calculator, you type in, let's say, sine x in the brackets and then squared. You cannot make this in the calculator. In the calculator, you will have to do sine x in the brackets and squares.
And then is theta x, like if you put theta on?
What do you mean? Instead of x, you don't have theta on your calculator.
You can get it, but
Or maybe you have, but doesn't matter. You put x.
Yeah, but-
X is theta. It's just angle.
Yes.
Okay, so it will, Pythagorean identity, allow us to find values of the, if you know value of one trigonometric function, to find values of all others. So for example, we know that our angle theta is in the third quadrant. So what will be the theta will be?
How do we do the quadrant?
pi plus theta.
This works for everything, for any point. But
the coffee of
in which range, so what will be theta between which value in quadrant number 3?
180.
It will be from pi
to pi, 3 pi over 4.
to 3 pi on 2.
sir.
And if we have that sine, we know that theta is in this interval, and sine theta equal, it has to be negative there. So let's say sine theta equal negative 0.3. And we need to find what will be cos theta and tan theta. Using Pythagorean identity, we have that cos squared theta plus negative 0.3 squared equal 1. Equals 1. So cos squared theta, cos squared theta equal negative 0.3 squared is 0.09. So will be 1 minus 0.09. So we have cos squared theta equal 0.91. Then what cos theta will be equal? Use your calculators, please. That will be I will say will be probably 0.92, so 93.
So negative 0.
Negative 0.
I don't know. Why?
0.9 what?
I don't know what it is, but I'm not connected.
Menu.
Take square root from 0.91, guys.
Okay. Crumbling under pressure. Reggie actually is crumbling under pressure.
Square root of 0.91.
0.95.
0.95.
How did
Yeah,
Daniel beat you?
0.954.
954.
Reggie, you're
Okay.
falling so low that.
But in the quadrant 3, cos is positive or negative? Negative. So it is negative 0.953. Does it make sense how we have found cos? Negative, because in quadrant 3, both cos and sine negative. Now, what is tan?
Wait, it has to be cos of
Tan theta equals sine theta over cos theta. So will be equal negative 0.3 divided by negative 0.953, and that will be something around 0.32.
No, McGraw, don't teach me how to do square root.
954.
Okay,
So that will be 0.3. What is after 3?
1, 1, 4.
1, 1?
No, 3, 1, 4.
3, 1, 4. So, and 10 will be positive because negative divided by negative is positive. Question, does it make sense what we did?
Yes.
Any questions? Question?
Yeah. How are you gonna answer? What the fuck?
Okay. That is Pythagorean identity, and how we can apply it. If we know one trigonometric function, we can find value of all other. No, not all, because we're not learning all in methods. We're learning only sine, cos, and tan. And there is more which learn only in special. There is a cotangent,
You put it to find
but it's not part of method.
X, we're finding cos of X.
Okay.
Right. Just
But I don't know how to do it properly.
Yeah. Which question?
Like Kaz, I'm like a grandpa. I'm not good at using technology, so I'm kind of good.
Okay, I'll look later. Okay. So now
I'll say too.
there are some more symmetry properties. There are more symmetry properties
what are we setting for this?
of the circular function. If we have, if this is angle theta, we have this angle theta, and what will be, let's say this angle, let's say alpha. What alpha will be equal?
90 minus theta.
Pi on 2 minus theta, yes. So alpha equal pi on 2 minus theta.
Okay, that makes sense.
Now, let's consider, let's consider
I don't know how to do it.
now two triangles. We have two triangles. One triangle and another triangle like this, and this triangle will be congruent to this triangle.
Oh, that makes sense.
Now, what this will, because this angle is alpha. So this side is adjacent. And this adjacent to the alpha equal opposite to theta in that triangle. I make another bigger
Wait,
rectangle.
what are we trying to find?
We have a rectangle. We have its diagonal, and we have this angle. This angle is theta. This angle is alpha.
Okay, so I agree.
And we have this side equal this side.
Okay.
And I put letters, so A, B, C, D. So we have triangle ABC is congruent to triangle ADC. Everyone fine with that? Agree?
Back and add curve
Now,
are the same.
what is sine let's look in the triangle ADC. What is CD relative to angle theta? Is it opposite or adjacent? Opposite. What is BA in the triangle ABC relative to angle alpha?
Adjacent.
Adjacent. But they are equal. They are equal.
Oh.
And length of diagonal equal what? Angle of diagonal equal
One.
1. This is 1. So we have AB equals what? Cos, it will be cos alpha. Cos alpha.
How the hell does that work?
What?
AB, we consider triangle ABC. AB is adjacent using SOHCAHTOA. So we have
Line AB.
AB.
K.
Yeah.
Adjacent equal hypotenuse times cos. Hypotenuse equals 1. So we have that AB equal cos alpha. At the same time, what DC will be equal from this triangle? From this triangle.
What?
No, and DC is opposite.
Opposite over
DC
hypotenuse.
equals sine theta.
Sine theta equals to.
But AB equals DC. So we got that cos alpha equals sine theta. And alpha is what? Pi on 2 minus theta.
Oh!
So we get cos
That was a difference.
pi on 2 minus theta equal sine theta. We got another symmetry property. We got another symmetry property of the circular function. That cos pi on 2 minus theta equals sine theta. In exactly the same way, we will get
Hey,
that
that's what you were
sine
just telling me before.
pi on 2 minus theta
That's crazy.
equal cos theta.
Okay, I'm gonna remember that.
By the way, what is equal cos, let's say pi on 6? What is equal cos pi on 6? Root 3 on 2. What is sine of pi on 2 minus pi on 6? What is pi on 2 minus pi on 6? Pi on 3. And what sine pi on 3 equal?
Oh!
Root 3 on 2.
Yes, it is true.
Sine 30 degrees equal cos 60 degrees
As
and
long as
vice
you don't
versa.
understand and just memorize the rule,
So
you'll never
when
confuse.
angles adds up to 9,
What a strategy.
when two
That's my
angles
strategy.
when two angles adds up to 90 degrees, sine of one angle will be equal cos of another angle.
He's actually
Two angles adds up to 90 degrees. We have that sine of one equal cos of another. Let's add some more symmetry properties. What will be sine pi on 2 plus theta equal? But we pi on 2 plus theta.
It would be minus.
It will be negative, so it will be equal negative cos theta, and so cos pi on 2 plus, sorry, guys, positive cos, sine is positive in the second quadrant. Sine positive here. Sine pi on 2 plus theta is positive. The cos pi on 2 plus theta will be equal negative sine.
Mr. V, how does sine
Okay, then
cos
that's
theta equal cos?
Huh?
How does it equal cos theta?
We can build another two triangles, draw the line, build rectangle, and we get the same thing. Opposite sides equal.
Damn, that actually makes sense.
Now, what will be
No, actually
sine of 3 pi on 2 minus
I did this
theta?
graph.
Sine 3 pi on 2 minus
That's just,
theta. What it will be equal?
I don't know, apparently he said you dissed.
Well, sine's negative, negative cos.
Negative cos theta.
Apparently you dissed me. So,
Okay, what will,
we're peak now.
can you please leave irrelevant conversations? Cos 3 pi on 2 minus theta. So you guys, you quiet.
Oh, yeah. I get it.
Stay humble. Eh?
What it will be equal?
Sine theta over 3.
No, it will be sine theta. But positive or negative?
Just take some credit for yourself, Gary. You're also very
We are in which quadrant we are? In third quadrant. Cos is positive or negative here?
Negative.
Here, cos x coordinate.
Negative.
Negative, so it will be equal negative sine theta.
Danny, wake up.
And plus
Danny, wake up.
Because how does the quadrant?
sine of 3 pi on 2 plus theta.
Okay.
What it will be equal?
In the rule there, it says pi over 2, but don't have to be pi over 2.
Here, we are here in the fourth quadrant.
It'll be
Negative cos. Sine is negative here, so will be equal negative cos theta. And cos 3 pi on 2 plus theta will be equal sine theta, because cos is positive. So, if there is pi on 2 or 3 pi on 2, 5 pi on 2, 7 pi on 2 involved, then function change, sine change to cos, cos change to sine. And then you just need to look in which quadrant you are, and you need to remember all stops to Caulfield. If you cannot look on the unit circle and identify the sine and cos positive here, and so in 10, cos negative, sine positive, 10 negative, cos and sine negative, 10 positive, cos positive, sine negative, 10 negative. So if you cannot look on the unit circle, then remember all stops to Caulfield. Make sense?
Yes.
So that pretty much all of what I wanted to explain today. Like, subscribe, and donate to help fight terrorist countries and organizations like Russia, Iran, Hamas, etc. Support Ukraine and Israel.